dear student. Today we are going to discuss the topic growth of function in and growth of function. In this topic, we are going to discuss how the functions uh, growths take place. We shall discuss this using some algorithms, pseudocodes, and we shall analyze that how to analyze and pseudocode and the increasing rate of the function, because the on the basis of the growth rate we decide the complexity of the algorithm. So to understand the analysis of the algorithm, how we derive the complexity of the algorithm from by analyzing the pseudocode of the algorithm, uh, we will understand here with an example of insertion sort. Here there is a code of insertion sort. In insertion sort, I have already explained you, but I am giving you a brief idea about the insertion sort. The insertion sort is the technique in which that we use while playing the cards. In it, we arrange the cards in increasing order. For increase for arranging the cards into the increasing order, we pick a card, and as we just pick single card, it is already sorted. When we take the next card, we compare this card with the previous card, whether this is larger than the previous card or smaller than the previous card. If it is smaller card than the previous card, then it is placed on the left hand side of the previous card, and if it is greater than the previous card, then it is placed on the right hand side of the previous card. If the with the next cards, we repeat the same procedure, and in it we check out the cards which are greater than the picked card are shifted to the right side by one position, and the cards uh, and by shifting of this card, an empty space is created, and that empty space is filled by the newly inserted card. So this is the simple logic. So here the pseudocode of the insertion sort is written here for an array starting from index 2 to the length of the array, in which there are unsorted elements. We do not start with the 1 because single element is already sorted. So for j equals to 2 up to length of the a, that is the length of the unsorted element array, we suppose that the cost is c1. Similarly, for each steps, we have assumed that the cost is C1, C2, C3, C4, C5, C6, C7, and C8. It's the cost terms, that's the terms used, that's the cost, and we shall have assigned the cost function to each steps. After I am just giving you a brief idea of this pseudocode, then when we initialize from index number 2 up to the length a, there is a for loop. It will run for the n number of items, n minus 1 items, and each item will be taken as key element one by one. Then we shall insert the element into the sorted array, and for each item I equals to j minus 1. So here again, for as each item is taken one by one, if there are n element, for each item the I value will be j minus 1. So that is, so it will be n minus 1 position. So I equals to j minus 1. For each element we shall derive the value of the j minus 1, and while I is greater than 0 and aj is greater than key, and we shall check a condition that if I is 0 and aj is greater than key, this condition will depend upon the particular number, how many times this condition will be satisfied. So this is the variable terms. So for this we shall use a term. Suppose we shall associate, for example, I am giving you the showing you the expression. First terms will run for the n items, because we are not starting from the first element, but at least it will also be inserted into the array. So first step will take C1, the cost function for n to n, for each n items. Second step will run from 2 to length of the array. Key element are initialized from the element number 2 to the length of array. So it is C2 into n minus 1. For single item, it is not considered as a key. This procedure is started from the 2 to n length of the array. So second step is run for the n minus 1 times. So the cost of the single terms into n minus 1 times. The third function is a statement function, and we know that this is not executed, so will not run for any of the numbers. So cost function will be 0. It will be done for the n minus 1 time, but the cost is 0. It will not be processed, so it is 0 from I equal to j minus 1. As I have told you, n minus 1 item will be the key element. So n minus 1 time we shall find out the value of value of I equal to j minus I, value of I on the basis of j. So this step will also take n minus 1 time. Here the condition while I is greater than 0 and aj is greater than key. This condition is checked. It depends upon the particular number. So here we have used the term summation of j equal to 2 to n minus 1 tj. It depends upon the terms tj. Similarly, the next step ai plus, if this condition is satisfied, then we perform the operation ai equals to ai plus 1. So whenever this condition, last condition C5 while condition is satisfied, this operation also takes place. So this is also replaced by the same function, but this will for the last term, this terms will not take place, so it is equal to tj minus 1. Similarly, the next statement, that is the I equals to I minus 1, is repeated for the same number of times. Whenever the while condition is satisfied, this condition also occurs. And after that, when this condition does not satisfy, then we move out of the array and the final position of the key element is derived, and ai plus 1 at position we put the final element, newly picked element. So this will run for the n minus 1 time, because it is run after the while conditions is not satisfied, so it will run only for the n minus 1 type of element. So the running time of the algorithm is if the Tn is equals to C1n plus C2 into n minus 1 plus C3 here is 0 into n minus 1, C4 into n minus 1, C5, C6 and C7. These are particular element dependent, so we have used a summation function here and overall. In this way, if the best condition is arrived, we know that the insertion sort gives us the best result when the array is already sorted. In these situations, the basically first 4 terms does not depend on the particular element, so they will remain as it is, but the terms C5, C6, C1, these are particular element dependent, but here the condition is here the condition here the condition is that they will only execute for this value will become equals to n minus, this will execute for the, if there are n elements, then this will execute for the n while condition will be satisfied, and all the element will be shifted to the 1 position. So in that condition, this will term equals to the n minus 1. So they will be replaced by the n minus 1, and the shifting, if they are already, they will occur only for the n minus 1 times condition is satisfied. So adding on all these numbers, we find out that this becomes equals to C1n plus C2 into n minus 1 plus 0 into n minus 1 plus C4 into n minus 1 and C5. Here we should notice that the C6 and C7 terms has been eliminated. These terms has been eliminated because the array is already sorted. When the array is already sorted, then we shall not get this, the while condition that aj is greater than the key, it will not be satisfied. This will be checked, but this will not be satisfied. So conditions, step number ai plus 1 is equal to ai equals to I equal to I minus 1 will not execute. We shall only check the condition that this condition is not satisfied. We should check the condition, but after verification, when this condition satisfied, then only these two steps are executed. This condition will be checked, but this will not be satisfied. So these two steps will not run. So the terms associated with the C6 and C6 will become 0. So the final expression will be C1 plus C2 plus C3, C4 plus C5 plus C8 into n minus C2 plus C4 plus C5 plus C8. So which is of the form an plus b. So this is a linear function. So Tn is equals Cn is of the order of n. We shall consider the is a linear function of and it's of linear group. It means in the insertion sort, in best case, it shows the linear growth. And the worst case, this is example of while playing the card, when when the cards are already arranged, we just traverse the array and find the location of the newly picked card. But that situation could be worst when the array is sorted in the reverse order. In that terms, first 4 terms will remain the same, but the fifth terms, the condition will be n minus 1, will be remain the same, but the condition associated with 6 will and 7 will be also be satisfied. They will also be of n minus, they will also be satisfied for the n minus 1 terms. So the final statement would be C1n plus C2n minus 1 plus C4n and plus C5 into n minus 1 by 2. Because for every item there are possibilities. We consider the average case here. If for half of the number, if condition is satisfied, that is equal to n into n minus 1 by 2. So with terms C6 and C1, we replace the value by n into n minus 1 by 2 for each of them. So this is the condition. We consider that the average, we consider that the average or mean of the times the condition is satisfied. We know with the help of mathematics that in this series we consider can take the average case as n into n minus 1 by 2. So while considering the situation n into n minus 1 is equal to n square minus 1 by 2. So considering all these, this is the form of the an square plus bn plus c. This is like a quadratic equation. So in the worst case, the insertion sort grows in n square terms. So by analyzing, we can say that the worst case running times gives us a guaranteed upper bound on the running time of an input. It means an algorithm will not take more than the quadratic time or n square times in execution of in sorting of any element in a given array. And in the case of sorted array, it cannot perform better than theta n. So why not analyze the average case? Because it often it's generally often the best like case. So in average case, it's also behaves like the same, and it is described by the highest degree terms of the formula for the running growth. So we have found that the insertion sort, the worst case running time is of the form an square plus bn plus c, and in the best case it performs in linear. It shows linear growth of order theta. So in this way we analyze the algorithm. Here I have taken the examples of insertion sort. Likewise, you may analyze any of the sorting.